Okay, first question then is scientific notation. So every single answer in this is... Sorry, somebody asking something there? Okay, every single question in this assessment needs to be completed to 2 decimal places at least. Okay, so make sure all your rounding goes to at least 2 numbers after the point. Right, first question we're looking at, we have distance between Earth and Saturn, and we want to write that number out in full. That number's gone a bit dodgy. Shouldn't be 2 decimal points in there. That should just be 7.4523 times 10 to the power of 6. Sorry about that. Okay, times 10 to the power of 6 then means I'm moving this decimal point 6 spaces. I move it 1, 2, 3, 4 to get rid of my decimal place, and then I fill in my remaining 2 with zeros. So we get 7452300. Okay, the next one, part B, the other way around, we want to write it into scientific notation. So it's going to be 6.72, and it's going to be times 10 to the power of, and it's going to be something negative because it's a small number. If I count the number of zeros, 1, 2, 3, I'm going to have to make this bigger. Oh, there we go, it's quite a bit bigger. 1, 2, 3, 4, 5. So we get 6.72 times 10 to the power of negative 5. Question 2, we're using our calculator to answer a scientific notation question. So we're doing 3.46 times 10 to the power of 3. Get the calculator going. We get 3.46. I've got my times 10 to the power of button here. Then I put in my 3 times by 4.12 times 10 to the power of 5. It equals we get 142552 and some zeros and 4 zeros. Now, it doesn't ask you to write your answer in scientific notation. If it doesn't ask you to write your answer in scientific notation, I can't penalise you for not. So you can leave that as your answer, or you can write it into scientific notation. I'm going to put it into scientific notation just because it's good practice, so we'll get more practice at it. So I'm moving this 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, so it'd be times 10 to the power of 9. Try the dividing one. I'm doing 8.27 times 10 to the power of 9 divided by 2.54 times 10 to the power of 5. It equals 32559. Point, and I need at least 2 decimal places. I'm just going to put 3. I'm going to put 0, 5, 5. Okay. You can also put that into your calculator as a fraction. So you can use your fraction button and put it in exactly as it's written there. But remember, a fraction and divide really are the same thing. Okay, percentages then. Number 3, calcium chloride is added to a beaker of baking soda. Lots of chemistry that I'm just going to ignore. Temperature increased to 658, and the percentage increase was 63%. We want to know what the original temperature was. Okay, so my original temperature was my 100%. I added 63% to it, which is 163%. That 163% was then 58 degrees. And my aim is to find 100%. Okay, and I'm going to do that by finding, that's my percent, what 1% is, and then what 100% is. So I'm going to do 58 divided by 100. No, I'm not. Why would I do 58 divided by 100? Try again. I'm going to do 58 divided by 163. That makes more sense. Zero 0.355828. 0.355 0.355828. Oh no. Three five five eight two eight. 2209. 09. Oh, your calculator's got more decimal places than mine. That's good. Right, that's what 1% would be. I want to find 100%. So I'm going to times that by 100. Now, I've written out that full number that I got in my calculator there. Okay, your final answer needs to be to 2 decimal places. So think what that would be to 2 decimal places. And make sure you have enough. Try and keep that in the recording screen there. So 35.58, that writing is terrible. So 2 decimal places. Any questions about that one? Number 4 is the work that we did last term. Still assessed this term. So if you are looking for a video on that, you won't have it from this term. It'll be back to last year's ones on appreciation, depreciation, or compound interest type questions. Okay. Given the right condition, the bacteria is going to increase 20% every 10 minutes. They're initially 150. How many are present after 1 hour? Okay, so we're increasing by 20%. So I'm going to add it on. So we've got 120%. If I divide that by 100, that gets me as a decimal. So my decimal is 1.2. So I want to do 1.2. Now, my power of my 1.2 is going to be the number of times it repeats. It's happening every 10 minutes for 1 hour. So it repeats 6 times. So I'm doing it to the power of 6 times the 150. We get 1.2 power of 6 times 150. I'm giving up with my memory. I'm just typing it into my other calculator as well. 447.897.6. H to 2 decimal places would be 447.90. Okay, so we're going to use our formula for orbital speed to work out eventually what the orbital speed is, but we've got a wee bit of work to do before that. Okay, so our formula is the orbital speed is the square root of g times n all divided by r. Now g and m are constants. G 6.67 times 10 to the minus 11 with some rather strange units, and m is 5.98 times 10 to the 24 kilograms. Okay, part A. The value for r, which must be given in meters, is found by adding the height of the satellite above the Earth to the radius of the Earth. Okay, so there's our radius of the Earth, there's the height above, and that gives us the r for our formula up here. We want to use the formula r equals re plus h to calculate r when the satellite is at height of 32,356 kilometres, given that the Earth's radius is 0.38 times 10 to the power of 6 metres. First thing I'm going to point out here are our units. Okay, the units don't match here. Before we find r, we want our units to match. Most of the time I would say to you, it doesn't matter whether you pick metres or kilometres. But for part A, it says the value for r must be given in metres. So if you work it out in kilometres, you then need to convert it again. So we're going to work out our height in metres. To work out the height in metres, I want to change kilometres to metres. How many kilometres are there in a metre? 1,000, yeah. So I want to times that by 1,000. To get that into metres. Okay, so then to find R, I'm doing the radius plus the height. Now we're back to scientific notation this time. So this time it is the times 10 to the power of button. So it's 6.38 times 10 to the power of 6 plus 32376,000. 32376,000, and we get 38756,000, and that is in meters. Okay, we're going to find this orbital speed. The orbital speed formula is orbital speed is the square root of gm over r. Right, g and m you've been given up here. So it's the square root of 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24, all divided by this number that we just worked out, 38756,000. Okay, from here it's a case of putting it into a calculator. I'm just going to extend my square root sign so it covers all of it. Okay, you can, on these calculators, put it straight into your calculator. I'm just going to move this over. But you can do it in steps at a time. You don't need to put it all in one go. Okay, so I'm going to do the top line. So 6.67 times 10 to the power of negative 11. I've had to put the negative in for this one. Times 5.98 times 10 to the power of 24. I'm just going to put that line in just now. That gives me the square root of, oh, I could keep that calculator on. 3.98866 times 10 to the 14 divided by 38756,000. So doing our divide, already got that top line in, so I'm just going to hit divide. 38756,000. So the square root of 10291, 722.57, and then we square root that. Yep. No, it's worth 3 marks. That's the part A. The part B is the 3 marks down the bottom. And you can type it, I can show you typing it all into your calculator on as well. Square root of that. No, wrong calculator. I've got my answer here already, so I'm just going to hit square root, answer 3208.07. And that would be in kilometres per hour. No, it won't. I don't know what it would be in.